Last thing we need to talk about for our electricity unit are circuits. So circuits are different electrical connections that complete the path of the charged particles. So the electrons that are traveling to the positive side, they need a complete path for that to work. If that path is broken at all, the device won't work and it won't be turned on. So it's a system of wiring, usually, that allows the electrons to travel all the way around. And they have these switches that can be added to open or close a circuit. So when a circuit is open, that electric charge can't travel through. When if it's closed, the electrons can travel, allowing it to get back to the device and it works. So kind of like a light switch. When I turn the lights on, when I turn the switch on, the lights turn on. So if the lights are working, that means when I flip the switch up, I'm closing the circuit. When I turn the lights off, I'm essentially opening the circuit because the electrons can't travel on, causing the light bulbs to not work at that time. So this is a visual of a closed circuit and an open circuit. We have two types of circuits that you guys need to know the definitions of and what they would look like visually. So my first type of circuit is called a series circuit. So it's like a series in television. It's a continuous flow, right? Series circuits, the initial amount of voltage is divided among the system. It's going to be one continuous loop here. If one part along the system is removed or it does not work, the whole system will not work. So I have this series circuit. The thing that you guys need to remember is it's just one continuous loop around. The initial amount of voltage is split up between the system. So imagine if this one resistor or this one light bulb stopped working, right? This is done, it can't work. If this part of my circuit isn't able to work, then the whole thing won't be able to work because the electrons can't get to the other side. Remember, for a series or a circuit to work, the electrons need that complete closed circuit. And if something isn't working here, then it's not going to be able to work for the whole system. For a parallel, it's going to look different. Notice that my resistors or my light bulbs are in branches. They're parallel to each other. This is where the voltage is the same throughout each branch. So I have different pathways. In a series circuit, I only had one pathway. For a parallel circuit, I have multiple pathways. Electrons can travel this path and get back to the energy source. Electrons can travel this path, right? There are two separate paths that they can take. So if one of these branches ended up not working, the electrons can still travel through the other paths, making it back so the rest of the system is still able to work. Some more visualization examples of these. So this is a series. It's one continuous path, right? It can also be shown like this, where this is a parallel. The electrons have multiple paths for it to continue to get back to the energy source. Same thing over here. Series connection, there's just one path. If one of these light bulbs went out, the rest of them won't be able to work. Have any of you guys ever, maybe Christmas lights? If a string of lights, if one of the light bulbs goes out, causing the rest of the light string to go out, that's a series circuit. Where maybe a parallel circuit that you're familiar with is if you're in a big building and you turn off one of the light switches, it doesn't turn off all of the lights, and that's going to be like a parallel connection. So if I look at these two, you should be able to identify what type of series it is, whether it's what type of circuit it is, whether it's series or parallel. So if I look at this picture, I see that there's one path, so I would identify this as a series circuit, where this one over here, I have multiple paths, so this would be a parallel circuit. And that's it. That's all of the concept we need to be familiar with for electricity.